back. Today we're going to talk about the rules of exponents, and I'm going to lead you through a series of exercises that's going to help you deduce the rules of exponents for multiplying and for dividing. Let's look at this chart. If we look at this chart, we're given 4 problems, and the 4 problems are listed on the left. And if I look at what these exactly mean, I've got 2 squared times 2 to the 4th. Well, if I go ahead and expand that out, I know that that's 2 times 2 times 2 times 2 times 2 times 2. That's not necessarily a new thing for us necessarily, but we end up having 6 of them. We have 6 2's. And so what I've got then, if I was going to write it as a power, I've got 2 to the 6th power. If I do the same thing for the 3's here, I've got 3 times 3 times 3 times just 3 because it's the first. There are 4 factors. So I've got 3 to the 4th. Now what I would like for you to try to do here is to try to relate the first problem with what you end up with as a product of powers. And so as I keep writing these down and what they mean, I want you to look at how these two things relate, these two columns. And I'm going to go ahead and just make it a little bit more abstract with the A here. And I end up with 6 factors there. So I've got A to the 6th power. So what I want you to do is completely abstract this. Instead of putting numbers in, I'm going to put in variables because it's x to some power n times x to some power n. And I'd like for you to write a rule that would tell me what would my final column look like if I was going to do it for x to the n times x to the m. All right? And then I've given you some problems down here that you can go ahead and try on your own. I will not do them until we get into class. Let's do the same thing for dividing powers. If I look at what this exactly means, I've got x to the 12th over x to the 7th, and this is going to be a little bit more involved here. Times x, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of these x's on top, and of course I'm multiplying between all of these, right? And on the bottom I've got 7 of them, so I've got x times x times x times x times x, x times x, 1, 2, 3, 4, 5, 6, 7. And as we learned before, when I've got the same thing on the top and the bottom like this in a multiplication problem, I can match them up and cross them out. So I end up with, I cross out 4 on the bottom, 4 on top. And so what do I end up with? Everything is gone, but I end up with 5 x's, and I've got x to the 5th. So after I crossed out, that's what I ended up with. If I do the same thing for these 9's, what I would like for you to be doing is see how you can relate this right-hand column to the far left-hand column. I've got 7 9's times 9 times 9 times 9 times 9 times 9 times 9. Okay, over 9 times 9 times 9. A little bit easier to see here. And I'm going to cross out. It doesn't particularly matter which end you start from because it just has to be the same multiplication on top and bottom. And what I end up with is 4. So I've got 9 to the 4th power left. Again, trying to see if we can relate this end result to what we initially had. A to the 5th, a times a times a times a times a times a times a. And when I cross out, I end up with 2 factors, a to the 2nd power. How can I relate that first and that last column? I'll let you do this. What I want you to have as an end result is a rule that generalizes x to the n over x to the m, using these previous examples to try to help you out. I want you to try to write those 2 rules down and bring them to class tomorrow. Then we're going to go through some of these problems. All right, guys? Thanks for watching. We'll see you next time.